Software runs pretty much everything in our world, right? From our phones to our cars to the entire financial system. But behind this digital revolution, there's this hidden crisis. An absolutely staggering number of the projects that build our world are, well, they're failing. So let's dive in and figure out what is going on.
Get ready for this number because it's a big one. According to research from the Standish Group, more than 80% of software projects in North America just fail to meet expectations, deadlines, or their budgets. 80%. I mean, that is just a massive failure rate for an industry that's so critical to our daily lives.
And this failure, it has a huge price tag. Research found that for every $1 billion spent on software development, organizations wasted an average of $97 million. Think about that. That's not just a small rounding error. It's a colossal waste of money and resources.
So with so much on the line, you have to ask, why? Why is this happening? If it's not a lack of smart people or a lack of money, what is the root cause of this massive, widespread failure? Well, that's exactly what we're going to unpack.
Here's how we're going to tackle this. We'll start with the surprising diagnoses that experts have made. Then we'll look at the need for structured blueprints and a moral compass. Check out the legal standards that apply, and finally, we'll pull it all together to create a profile of what a successful modern software engineer really looks like.
So, what's the diagnosis here? You might be surprised to hear this, but it's not really about the code. It's not about the hardware. The real issue is actually much more human. That's right. The data, again and again, points to one main culprit, a lack of what we call soft skills. Now, this insight is a total game changer because it forces us to shift our focus away from just the technical stuff and toward the people doing the work. Just imagine a project where the client's needs are totally misunderstood, not because the engineers aren't smart, but because nobody asked the right questions or really listened to the answers. That's a soft skill failure, and it can sink an entire project before a single line of perfect code is even written.
So what are we really talking about when we say soft skills? Well, they're those personal traits that let people work well together. We're talking communication, negotiation, solving conflicts, making good decisions. They're like the human lubricant that keeps the complex machine of a project running nice and smoothly. And to really get a handle on this, researchers even developed a framework. They started by sorting these skills into 4 main buckets: communication, social skills, thinking, and leadership. This gave them a structured way to really analyze just how big of an impact these human factors have. Then, to zero in on what really matters, a panel of 25 software engineering experts got together. They identified these 6 skills as the most critical. Things like active listening, clear communication, and logical reasoning. And the key takeaway here is that these aren't just nice-to-haves, they're absolutely foundational for success.
Okay, so having the right skills is obviously super important, but it's not the whole story. For those skills to really make a difference, they need to be used inside of a structured process. It's kind of like building a house. You can have the best builders in the world, but you still need a solid blueprint to guide the work. And the industry's official blueprint for this is a standard called ISO/IIC/IEEE 122007. It's a big international framework that covers the entire software lifecycle, from the first idea to the final product, making sure everyone is working from the same set of plans. What this standard really does is bring order to what could be a really chaotic process. It breaks everything down into 4 key areas: making agreements, the organizational stuff, technical management, and of course, the actual hands-on technical work. Each part is critical for keeping the project on the rails. Now, a blueprint is essential, but even the best plans have gaps. What happens when you run into a situation that the plans just don't cover? Well, that's when an engineer needs a moral compass, a set of guiding principles for making tough professional judgments. And wow, this quote really says it all, doesn't it? This comes from the Code of Ethics from 2 of the biggest professional organizations, the ACM and IEEE. And it makes it crystal clear. Software engineers have a lot of power. The stuff they build can either do a lot of good or cause a lot of harm. That's why having a strong ethical code is just non-negotiable. This code is built on 8 core principles that cover a whole lot of ground. For example, engineers have a duty to the public to make sure their software is safe and reliable. They have a duty to their clients. There's even a principle about lifelong learning, which highlights the need to always be improving. It's a really comprehensive guide for how to act ethically.
So that ethical code gives us the moral framework. But where does the law draw the line? That brings us to our final layer, the professional standard of care. This sets the legal baseline for what's expected and where legal trouble can begin.
So what does the standard of care actually mean in plain English? It's basically defined by what an ordinary, reasonably careful professional would do in the same situation. And notice those keywords, ordinary and reasonably. This is so important because the law doesn't expect perfection, but it absolutely does expect competence. This slide shows the huge difference between that reasonable standard and what some contracts try to demand. On the left, you've got the standard of care. It's what liability insurance is for. But on the right, you have these really risky demands like the highest standard of care or a guarantee that something is free of errors, basically a promise of perfection. Most professional liability insurance won't touch that stuff with a 10-foot pole. And this is a massive source of conflict and risk. In fact, this whole problem has gotten so bad that some states have actually passed laws to protect professionals from these crazy contract demands. These laws basically say you can't force a professional to take on an uninsurable level of risk, reinforcing that negligence, not perfection, is the basis for liability.
Okay, so we've looked at all these different layers that define modern engineering. Now let's pull them all together and assemble the complete profile of the professional who's behind the code.
This building analogy just sums it all up perfectly. The soft skills, that's the mortar holding all the bricks together. The processes are the blueprints that guide you. The code of ethics is like the building code that makes sure everything is safe and has integrity. And the standard of care, that's the final inspection. You need all four to build something that's actually gonna last. So here's the bottom line. Building great software is so much more than just writing code. It takes a true professional who is also a skilled communicator, who follows a structured process, who's guided by integrity, and who really understands their professional responsibilities. And that leaves us with one last question to think about. The technology that defines our entire modern world is, at its heart, a human thing. It's built by people for people. So, are we focusing enough on developing the people who are actually building it all?